Today's section, we're going to talk about events involving not or odds. Let's look at examples. 1. If you are dealt one card from a standard 52 card, find the probability that you are not dealt a queen. So this problem, you have two ways of doing it. Which this exact problem is easy enough when you say not a queen, then we know we have 4 queen. There will be 4. So not is going to be 48. So you're just subtracting that queen out of 52 cards. So what's left over is 48. So your probability can be 48 over 52 and reduce, right? So you can do this way. But if I wanted to use this formula right here, not, right? Then what I can do is, okay, let me write that down. So if I wanted to do not delta queen is going to be equals to 1 minus getting a queen. Why do we do that? Because sometimes this number right here is way smaller than actually dealing with not, right? So you can see not was 48 versus 4. So then we will say 1 minus probability of getting queen is 4 over 52, which is going to be 1 minus 1/3, right? And this is easy enough. You will say 1 is same as 13 over 13, since you need to have same denominator in order to subtract fractions. You change 1 into 13 over 13, and then it gives you 12 over 13. And I know if I reduce this, that's what I will get, 12 over 13, right? So either way, you will get the same answer. And sometime this method is way easier because this number being smaller, this probability is smaller. Let's do another example. Example 2. If 2 fair dice are rolled, find the probability that the sum of the numbers shown is greater than 3. So when it says greater than 3, and when you're rolling 2 dice, since each dice have up to 6, it could be 12. So when it say greater than 3, it could be 4, 5, 6, all the way to 12. And we need to find what will be the probability of getting 4, what will be probability of getting 5, what will be probability of getting 6, and all the way to 12. This is going to be a lot of work, but if we look at it as less than equals to 3. So that's going to be the other direction of this one. This say greater than 3. And since the greater than 3 is same as 1 minus less than equals to 3, and we know that less than equals to 3 is going to be, only option is starting from, well, you cannot get 0 when you're rolling 2 dice. You cannot get 1. So it will be starting from 2, right? So you're going to get either probability of getting 2 or probability of getting 3. So finding a probability of getting 2 and 3 is last outcome than when you're looking at finding probability of getting 4, 5, 6, 7, 8, 9, 10, 11, 12, right? That this is a lot compared to 2. So that's why we're using this formula. This is when we're going to actually really use not. Okay, so then let's see. We will do 1 minus, let's see. Let me just write down this 2 case. So when are we getting 2? We're going to get 2 when the first dice is 1, second dice is already 1. That's one time you're getting 2, right? This is when you're 2. And then you have another case when you're getting 3. So this is getting 3. Getting 3 is going to be when first die is 1, second is 2. Total of 3, right? Or you can get first die is 2 and second die 1. So just 3 of them. And total number of outcomes when you're rolling 2 dice is going to be 36 case. And if you want to, you can write the case down, but that's going to be total. So then you can subtract 3 out of 36, which is same as 36 over 36 minus 3 over 36, which gives you 33 over 36. Again, you reduce 11 over 12. Right? And if you wanted to see that 36 outcomes, right? So I'm not going to write all 36, but you can imagine. So if the first is 1 and 1, and then the other one is when first is 1, second is 2. And when first is 1, second is 3. And so on all the way to 1 and 6. So that's going to be 6. You have 6 options. But this can be when first is 2, right? All the way to 2 and 6. That's another 6. And then you have all the way to when first is 6 and second one is 1. And all the way to first one is 6 and second one is 6 also, right? So right here you're going to have 6. And from here to here you're going to have 6. So 6 times 6 is going to be 36. So that's how you get total outcome, this number, total outcome. Or even this number, total outcome. Example 3. If one card is randomly selected from a deck of cards, what is the probability of selecting king or a queen? So this is important. Remember, this section topic was dealing with the problem not. We already looked at 2 problems with the not. Or is the other one, or, right? So what happens if we have or? We can get king or queen. How do we find the probability of that? Whenever you have or, we're going to add the probability of getting king and probability of getting queens. And that's the formula, you see it here, right? Or you're adding. So let's see, this one right here, it said, so we're going to do probability of getting king or getting queen. It means we're going to find the probability of getting king plus probability of getting queen. probability of getting king is because you have 4 king from 52. That will be 4 over 52. And plus, same thing with probability of getting queen. There is 4 queen, 52. And when you're adding it, it gives you 8 over 52. And make sure you reduce your fractions. So you get 2 over 13 there. Example 4. If you roll a single dice, what is the probability of getting either 4 or a 5? So there's another or. So in order to find the or probabilities, we need to add those two. So probability of getting 4 or 5 is same as probability of getting 4 plus probability of getting 5. This is single dice, so it will be 6 side and 1 out of 6 plus 1 out of 6, which is 2 over 6. That's 1/3. Okay, this example 5, we've seen it before from the other sections, which is marital status. And this time we wanted to find divorce or male. So this time we wanted to see divorce or male. So when you're looking at divorce right here, we have one with the male and one with the female. And we have divorce total right there. And we have total of male right here. So let's write this down. So in order to find the probability of divorce or male, we need to find probability of divorce plus probability of male. So then probability of divorce is going to be 24 total, right? 24. And then you're going to find the total of the research was 242 million, right? 242. Plus, you're going to have 118 over 242. So let me just circle that too first. So when you're looking for divorce, first, male, right? And we know we're using the total number of it. That's why we use 24 and 118. So when you're looking at this, what else you know is that we have one area that's overlapping. So this area is overlapping. So I end up using 10 twice. So what I need to do, subtracting that 10. So subtracting that 10 over 242 probabilities. And that's going to be probability of divorce and male. And that's what you need to subtract, because you end up using 10 twice if you just have this 2, right? You use 10 here one time, divorce, right? One time this 10. You use 10 here twice. This is the total number, right? So you're using 10 twice. That's why you're subtracting 10. So before we finish the problem, let me go back to the formulas. Right here, it's say if we have are not mutually exclusive events, you're going to subtract n. And when you have mutually exclusive band, you're just going to add those two when you have OR, right? But even the OR, if it's not mutually exclusive band, you need to subtract the overlapping area. So that's why we are subtracting. And then let's see what else we get. When we do adding and subtracting of this too, you get 132 over 242. And when you reduce this, you get 6 over 11. So you can leave it as 6 over 11, but you can also write it into the decimal form of 0.55. Okay, so then with the same chart, let me erase and go over B. This time we're looking for probability of marry or divorce. Let me mark the marry and divorce and see if it have any overlapping area. That will tell you if it's independent event or it's not independent event. So this is going to be married, and this is going to be divorce. So that's independent because you don't see any overlapping area. It means you just need to do probability of marry plus probability of divorce. And probability of marry is 130 over 242 plus probability of divorce is going to be 24 over 242. When you add those numbers, you get 154 over 242. If you wanted to give me the fraction as the solution, this becomes 7 over 11. Or if you wanted to answer into the decimal form, it will be 0.64. And either way, it will be okay in handwriting. I believe my math lab will ask for decimal form. So this time, if we wanted to look at married and female, married or female, right? So first thing we wanted to know is if this is independent event. So marry is going to be right here, and female is going to be right here. So this is not independent event. Why? They have overlapping area. So this is not an independent event. So when you're writing down, you need to make sure you're going to subtract the end part, right? Overlapping part. So probability of marry or female comes from probability of marry plus probability of female, but this time you need to subtract probability of marry and female. And we know that probability of male is 130 over 242. Probability of female is, you have right here. Right here is female, right? So it'll be 124 over 242 minus probability of married and female is right here, 65. So it'll be 65 over 242. And when you do adding, subtracting on the numerator, you get 189 over 242. And when you divide those numbers to get decimal solutions, you get 0.78. So now, example 6, we're going to look at the example that is involving odds. So we have odd in favors and odd against. And if we look at formula right here, this is what odd is, right? We have odd in favor and odd against. So So that's the formula we're going to use. Let's go back to the problem. So example say you're rolling a single dice. Find the odd in favor of rolling a 2. So if we wanted to just find out the probability of rolling a 2, it's going to be 1 out of 6. And probability of rolling not 2 is going to be whatever that it's not. So it'll be 5 is left over from 6, so it'll be 5 over 6. So, and if we wanted to find odd in favor of rolling a 2, so we're trying to find out odd in rolling a 2, right? Then what you're going to do is only counting on numerator right here, right? So that's going to be odds in favor of rolling a 2 is 1 to 5. So 1 is going to be the case that it's going to be 2, and 5 is going to be case that's not going to be 2, right? Okay, then let's look at the other one. What about this time odd against? So we are looking at the same probabilities. But then when it say odd against, so then we're going to put this number first, not 2. It's not going to be 2. We're going to write that first. So it's going to be 5 to 1. Okay, so once we understand odds, let's look at different types of problem here. Example 7, the winner of the raffle will receive a new sports utility vehicle. If 500 raffle tickets were sold and you purchased 10 tickets, what are the odds against you're winning the car? So we're looking at odd against this time. So in order to find odd or odd against, you're going to know what will be the probability first. So we need to know what's the probability of winning. Probability of winning is because you purchased 10 and out of 500, that's going to be your probability of winning. It means the probability of not winning is going to be the other. So it will be 49 over 50. So since odd, we're going to use only the numerator part. And because they're asking for odd against, so this means what would be the better chance not winning, right? So we're going to end up using 49 first. So we will set odds against winning is 49 to 1. And that's what they're asking. Let's look at one last question from this section. Example 8. The odds in favor of a particular horse winning a race are 2 to 5. What is the probability that this horse will win the race? So this problem is going the other directions. Your odd is given and you're trying to find the probability this time. So when you're looking at the other problem, remember from probability of winning was 1 over 50. Probability of not winning is 49 of 50. So this numerator, if you're adding these two, you get total numbers. Again, if you're adding these two, you get total probabilities, right? Total outcomes. So then this is going to be working same thing. If you're adding this 2, that's going to be total outcomes. And it says odd in favor, so this is going to be what your favor is. So you can write this probability as 2 over 2 plus 5, which is 7, will be the probabilities.